our topic is electric flux through a surface enclosing the charge. Basically, this one is the sphere and Q charge is enclosed by that sphere having radius r. This one is the explanation that the sphere of radius r having the positive charge. This one is the positive charge enclosed by the it. The figure, this one, in this figure we can see that the electric field due to positive charge is always away from the charge, and the vector area is also perpendicular to the charge, and that vector area is parallel to the electric field. These are two things. Basically, this one is the magnitude of vector area, basically area, and that area is perpendicular to the electric field lines, but the vector area is parallel to the electric field lines. So the electric field lines due to positive charge along the, always along the radius of the sphere and perpendicular to the surface of a sphere as shown in the figure. So the surface of the sphere is curved. This one is the curved surface. So we will divide it into n small patches. Okay, n small patches having magnitude a1, delta a2, delta a3 up to delta an. The corresponding vector areas of these areas are delta a1 vector notation, delta a2 vector notation, delta a3 vector notation up to delta an vector notation. The electric field lines are electric field intensities from vector areas delta a1, delta a2, delta a3 up to delta an are E1, E2, E3 up to En respectively. So I am going towards the derivation. The electric flux from delta A1 is the phi E1 is equal to capital E electric field, that is the dot product of electric field lines and vector area. So the E1 dot delta A1. The electric flux from the delta A2, the phi E2 is equal to E2 dot delta A2. Similarly, the electric flux from delta AN, nth patch, that is phi En is equal to En dot product and vector area delta An. To find the electric flux, total electric flux, basically this one is the total electric flux, just add the above all the equations. These are all the equation 1, 2, 3 up to n. We will get that the total electric flux is equal to delta phi E1, phi E2 up to phi En. Okay. So this one is the total electric flux, and just putting the values from equation 1, use 2 and use n. Okay. Just putting the above these values of electric flux, we will get these results. And so the angle between vector area and electric flux, electric field as shown in the figure is theta is equal to 0 degree for each patch. Okay, here E and A are parallel. So in each patch the area is parallel to the electric field lines, so the angle between both two quantities will be 0. So just opening the dot product, we will get E1 delta A1 cos of 0 degree, E2 delta A2 cos of 0 degree, and En delta A cos of 0 degree. And cos 0 degree is equal to 1, so this one will give us 1, this one will give us 1, and this one also give us 1. So the next equation we will get by simplification of the previous equation. We will find this. We will get the new equation E1, E2, E3 and with magnitude of area. If charge is placed at the center of the sphere, as in this figure, charge is placed in the center of the sphere, so we can say that the electric field at the surface is equal. The magnitude of E1, magnitude of E2 up to magnitude of En is equal to E. Okay, put this these values in equation number 1, we will get E, simple E. Okay, and these are the some common values. Just take common of these E's and we will get E is equal to into delta A1, delta A2, delta A up to delta AN, and this one is the total area, surface area of the sphere, the whole surface area of the sphere, because these were the patches, and these patches by adding will give us the total area of the sphere. So the value of total area sphere is 4 pi r square, and electric field, by the definition of electric field, we know that 1/4 pi epsilon naught q/r square. So these are some same quantities and cancelled out, and r square will cancelled by the r square in numerator and denominator, and this one is the final result of electric flux due to charge enclosed by the any sphere. And vector form, here the students are very confused and mistakes due to by adding the unit vector here. This is not a correct value, because this is the electric flux is scalar quantity, so having no vector form. And MCQ can be asked in the examination, like if flux is q/epsilon naught, so the vector form of this form is this one. So if this type of question will come in the examination, you should just write down none of these. Not this one is not correct option, because this is scalar quantity having no vector form. Okay.